Okay, this is one of the trickier parts of this unit here. All right, so watch what happens if we try to factor a common factor out. Okay, if we try to say, oh, let's try to remove this out of everything. Oh, wait, 3 does not go into 17. 3 does not go into 20. So what do we do? In this situation, we have just tried to find a common factor to factor out. That doesn't work, right? Nothing goes into all three of those things except one. So how do we handle this? All right, this is called grouping, and you're going to see why it's called grouping near the end of the problem, actually. But here's our technique. First step, let's take A times C. So we start with the beginning number times that number. That gives us -3 times -20. We end up with 60, positive 60. Okay. What that tells us is we now need to look for two numbers that multiply to equal 60 that also add up to 17, excuse me. And start thinking of those numbers real quick, right? 160, 2 and 30, 3 and 20. Not quite. How about 12 and 5, right? So 12 and 5 work. 12 times 5 is 60, and 12 plus 5 is positive 17. Now, from here, we're going to do things a little different. So let's rewrite the whole equation, the whole polynomial, but instead of 17x in the middle, let's put those two numbers right there as coefficients of x. Then it gets to the part where we group. All right, so when that happens, we're going to group up these two things just like this. And we're going to treat them as two separate factoring questions. Now ask yourself, what goes into this first group here? What's a common factor? Well, x is a common factor. Also, 3. If the leading term is negative, let's pull out a negative term also. So I'm going to say -3x is a common factor in that first group. Right here. What would be left over? Well, there would be an x, and there would be a -4 left over, right? Again, we are undistributing in that case. Not a real word, but that's what's happening. We are factoring. We're going to do the same technique here in the second part. We're going to say, what do these two have in common? And that is positive 5. And if we notice, here's what's left over. The exact same thing. If you do a question where we're trying to factor quadratics by grouping, you should end up with the same factor left over in this step every time. All right, that leaves us with x minus 4 as one of the factors. And the other part, -3x plus 5, that's what's left over as the other part of the factor, as the other factor in the problem. So we now have these two factors. We could always double check it to make sure it matches here in the beginning by distributing, right, just like this. Notice what pops up when we do that. 12 and 5. See the connection there. And if we combine these two in the middle, it does match. All right, so just to be clear, your answer on this one would be these two factors down the bottom right of your screen right there. And that's quadratics by grouping. Kind of challenging, but it is the same process every time. Start by multiplying these two, A and C, and then see if you can lay out what numbers belong there. Split up the factors that we get, 12 and 5 again, and then we group them up, find the common factors, and then there are your binomial factors that we're looking for.